Excited. Okay, let's get the content for this month going. It is January, so I do a quarterly update from my end. So at least 4 times out of the year, we've got something going on. I like to call it the Frymatic update. Frymatic is a character that I came up with once upon a time when I decided I wanted to make some music, but also write some code. And I made a SoundCloud and a GitHub account at the same time and named them the same thing. And so this is Q1 2024. I almost put something in for 2024. I guess I wanted to just call out some fun updates. Google just recently made it so that they're not sharing or they're not storing cookies anymore. So that's wild. I think someone was doing some cybersecurity research stuff. There might be some interesting opportunities in there. Let us know if you figure it out and feel like sharing. Although if you figure it out, maybe you don't want to share. Who knows? Also, in 2024, Steamboat Willie is now in the public domain, and there's already a horror movie out about it. Exciting stuff. I don't know. Maybe I'll try to do something about that in the future. Okay, so I got two main things that I've been working on in the last quarter or so. So I wanted to share some bit of a slideshow for both of them. One's a real world project, a little bit more physical engineering than Python stuff. And then the other one is a little bit more digital and has a good amount of Python built into the main project as well as what I'm contributing to the end thing. And so first is a geodesic dome that I've been working on down in Southern California in a little town in the foothills of San Diego called Elfin Forest. It's been fun. I visited there a number of times. I tend to work like this with projects. I go and visit, I call it a business trip, hang out with friends and work with them on their projects. This is the person I met at Burning Man this year. Um, Out of it, it was like muddy and windy and rainy, and tarps were flying everywhere, and we were all hanging out at some bar. And I guess I was climbing around on the structure and fixing things. And he was talking to my girlfriend, and he's like, "Whoa, look at that guy." She's like, "Yeah, that's my boyfriend." He's like, "Does he always do that stuff?" She's like, "Yeah, he just kind of fixes things." He's like, "Oh man, I wonder if he'd want to help me build this dome." So he had a geodesic dome that he was moving from one property to the next, and they're pretty popular at Burning Man. So this is a project wherein we build one. More of a slideshow than a Python thing. I promise we'll get to some Python stuff, and then Robert will get really deep into the Python for anyone who's um, concerned about it. So that was our space. As you can see, he had a whole bunch of stuff. Mostly, we were building this dome for an extra 800 square feet of workspace. Um, but as you can see, there's a whole bunch of stuff sitting out there. That's approximately where the dome is now. It's actually a little bit more to the left. Um, This was a sort of superimposed location. It got moved later. There were some delays. It's good times. There's a bit of conversation with the landlords about where the thing should be and visibility. We got there in the end, but yeah, this wasn't where it was. Ended up a bit more to the right. Um, we had a false start early on. We had some friends help us out building a platform that ended up getting scrapped because of that. We replicated it a little later, but these guys did a little more reasonable job. But we got something finished. We use these things called platens. That is to say, it's an assembly of plywood with 2x4s nailed to it. They're incredibly strong. I think we've had like 3,000 pounds on one of them without much play. We painted them up with some termite stuff. See how well that works over the years. But got them ready. There's our friend trying to work out the paint gun. He's the one that owns the dome. We ended up just slathering it on with regular rolling paint. And there we are. We've moved it to the right. As you can see, it's slightly more amateurish approach, but it ended up working. Um, he definitely took one for the team by getting under these things and screwing them together side to side. He was under there on a regular basis. I like getting dirty and rolling around and climbing on things, but I didn't really want to do that when I'm glad he was up for it. Yeah, it's coming together. Look at that super tiny work site. Yeah, platform's looking a little bigger. I wish I had gotten a better picture of it finished, but we'll start into the dome next. All right, so this is the diagram of what we were working on. Geodesic dome is something that came out of the mind of a he's like engineer and like mathematician and all other sorts of heady stuff. This guy named Buckminster Fuller, and he figured out that you could modify the shape of an icosahedron with sort of constituent triangles of varying sides and length. They're not quite equilateral triangles. All of those different colors are different lengths, but you could effectively make what was a hemisphere that would lie flat at the bottom out of simply triangles. And so if you see there's most of it is hexagons the way the triangles go, but every so often there are pentagons. And those are sort of the vertices of an icosahedron, which is to say a 20-sided polyhedron. Um, if anyone plays Dungeons and Dragons, you'll recognize that as the 20-sided die or D20 that you use for rolling initiative. Icosahedron, that is. This is obviously not an icosahedron. This is what's called a geodesic dome. Um, so to get started with that thing, the base on this, I don't know if you've noticed, but that was a pretty big base, 30 feet across. And so a dome of that size is a lot of material. And so we had to use a contractor lift to pick the thing up in the middle. And you can rent these things at Home Depot or wherever your regional thing is. And yeah, they're pretty fun, pretty impressively strong. So we started building the thing from the middle. You see we had it strapped on there in the middle. Um, Also, you may notice that the angle of this thing is already kind of narrow. Um, it's partly because there's a bit of play as these things hang, but also because as we got a little further on, we realized, wait a minute, this is not the right diagram. And so enter ChatGPT. I think Nick is gone, but Nick pointed out that ChatGPT can be a great tool for explaining what's going on. And so in this case, I thought to myself, like, I don't think we have the right instructions here because we have more pieces or more types of pieces than is described on the diagram. So I said to ChatGPT, I'm trying to help a friend construct a geodesic dome. The radius is supposed to be 16 feet. We have parts labeled A through F. There are 30 pieces labeled F. The diagram we have lists only pieces A through E. Could you help us identify the likely size and frequency of the structures so we can get the right diagram? And, a little bit of back and forth. Wouldn't you have it? It ends up pointing me to this website called Domarama, which is all things geodesic domes and other kind of DIY projects, and finally got to the right diagram. And once we started working on the right diagram, well, things shaped up a little bit better. So,
So,
quick,
so it came with IKEA instructions.
yeah, worse than IKEA instructions. It was like, choose your own IKEA instructions and hopefully you get the right ones. And we got the wrong ones out the game. Not awesome. But we got there in the end. We just had to back up a little bit. I think we maybe got like 2 layers down before we had to start over. Um, but yeah, so little time lapse as it comes together. Oh, I think that's it all the way to the ground. Yeah, that's all the way to the ground. As you can see, there's a little bit of interaction with that little house to the right there. Um, and so we had to kind of navigate that. You can see the contractor lift in the middle. It's like at full extension there, but basically the entire weight of uh, that that dome, all that steel was able to be held on that contractor lift, but also sitting on one or two of those platens. Um, pretty pretty good strength for something you can rent for 75 bucks a day and a couple platens that we put together. um, One of the features of these domes is they're incredibly robust. You can take out a few pieces and they hold their shape and they're like climbable and whatnot. So You can see in the front there, we knocked out a piece so that we could get that big lump of material into the middle there. That big lump of material probably weighed like 400 pounds and is the cover for the thing. It's material from an old billboard, and you can buy them from advertising companies. They'll sell them to you for like pennies on the dollar for what they initially spent in creating them. But this is really thick uh, ripstop vinyl stuff. Um, Pretty impressive. Just getting it into the middle there was kind of a task. It had been sitting there as the construction was halted a number of times. We ended up having to pull it on a system of pulleys attached to, yeah, oh, hovering time, yeah, an incredibly strong lift. I don't know what it's rated at, but more than a dome, that's for sure. Um, but yeah, this thing was incredibly awkward. The pile of crap was really heavy, and we ended up using a truck to pulley it into the middle there. And we finally got enough hands on deck that we were able to start unfurling this thing and pulling it up the side. There's my friend Chad there, the owner of the place, posing for us. There it is from the back side. As you can see, the front side, there's printing on it because it was billboard. But obviously you don't want that sticking out. We'll put the white side out. And there's our friend Omar helping out. As you can see, continues going up, getting there. Oh, there's the tarp attached to the truck. Here it is at night. It's almost there. Getting pretty close. We started using really long 2x4s to poke at it to get it unstuck at the joints. The joints are held together by these pretty decent gauge bolts. Oh, Hatham has a question. What's up, Hatham?
Sorry, two questions. Um, what's the design you guys were trying to put on the tarp, and what's up with the mannequin legs?
Okay, so first off, the design is arbitrary. It comes from an advertising company. This was a billboard, the material, and so that's just what he got. And the mannequin legs, the friend runs an apparel company, yoga apparel. So I guess leggings are sometimes involved, and so mannequins are useful. Um, and there, it's pretty much up. This was actually the setup for the last SacPy. I did that from within the dome. Um, and then here's a picture of it at night. So it's been a fun project. I'll probably be heading down there again relatively soon. Hopefully to be working on the apparel company next and finally getting these SacPy shirts done. All right, so next up, a little bit more technical project I've also been working on during the Dome project is with a company called GameForge.ai. We're kind of jumping on the generative AI craze, working on a game development tool that we're hoping to offer as like software as a service to game developers. You can find us at gameforge.ai. That's www.gameforge.ai. And the idea is that generative AI allows you to create assets, a fraction of the time it would take to work with a normal team. And we're hoping to be able to accelerate as well as accelerate the development process for a game, as well as increase the quality by allowing a team to generate more than normal. We're currently focused on integrations with Unity as well, and I'm working on the integration with Roblox. If you're familiar, it's kind of a kids platform, but it's one of the biggest gaming ecosystems in the world right now, 200 million users. And it's been a lot of fun. But yeah, so I wanted to show you guys some of the things I've been working on with that. This is from our pitch deck. Here's about where it sits in the game development team. Story writers, artists, game developers would be the ones working hands-on with those. And I guess the green people there are the ones that are likely to pay for this tool for them. So here's what the tool looks like in practice. This is a number of concepts that I've been working on, kind of dumped into the project. There's one of those dome type structures. Um, you can see on the left there, there's kind of an outline and a hierarchy of various entities. There's quests, there's locations, there's items, there's characters, there's groups and all of that. And there's a really neat flow where you can, kind of highlight an aspect of it, generate a new entity that rests under it. Really interesting flow. I encourage everyone to check it out. It's free to use for the first some number of entities. And then if you're in the game development space and you've been hoping to get something like going, we've got our early adopter pricing. So we're open to additional customers. We just got our first customer in the last month or so. So on my end, like I said, I'm working in the Roblox space. It's a three-dimensional platform. It allows for people to relatively easily create their own games in the 3D space. It also allows for, two-dimensional and like interesting other ways to like utilize the platform. It's pretty wild to see what people have done with it. But I wanted to focus on that graphic that came up there at the top center. Yet another dome.
So
Um,
I got a question about the first dome.
sure.
So what was the motivation to create a specific type of space, or just to evaluate how hard it would be to make a geodesic dome and cover it?
Well, as far as my interests go, I'd say I was interested in just getting practice building them. They're really popular at Burning Man as like structures that you see out there. I
Right.
built one or two of them in the past, and then this one was a lot bigger than the ones that I had built. And so when he approached me with the idea of working on this down in San Diego, I said, one, I like San Diego, and two, I like building things, and three, I like building Burning Man things. Um, so, and then for him, it was, I don't know, he's like an artsy character, burner, and this was something he had had on his property for the last 10 years or so, and then he was moving, so he
So
had, yeah,
I think Burning Man is about you build it and then you take it apart and take it back with you, right?
that's right, leave no trace.
Leave no trace. So the speed with which you can construct and then deconstruct in an organized manner is pretty important.
No, absolutely. Also, it's a little bit easier to build out there on a certain level, um, because the lake bed that it's on is pretty much dead flat. This thing was on a rocky bit of dirt that was also on a bit of concrete and a bit on a hill. Oh, Hovering says, I initially volunteered at Burning Man by helping create a dino that shoots fire from its tail. That sounds about right. Was that a static structure or was that an art car, like something movable? Static, yeah, but shooting fire, yeah, that's definitely Burning Man for you. So what I've been focused on is sort of taking that tool and making it work with the three-dimensional space. And so generative AI has a whole, it's sort of a multimodal thing. It used to just all be about large language models and could generate images, you could generate text, but now you've got ones that you could generate three-dimensional models, and then there's even some that we've run across that can take three-dimensional models and rig them up for animation. And so I've been kind of playing around in that space. So this thing was
Pretty cool.
called CSM.ai, and it would take a picture. That picture was generated from the game forge itself, and then generate a low poly model. It would then allow you to, in the unpaid tier, generate a refined model, take a little bit of time. Um, and so it did that later, but this was the early, like, unrefined model. And this is what it looked like in game, or not in Gameforge. This is in an open source 3-dimensional rendering tool called Blender. And I was kind of excited about the 3D aspect of this project because it would give me an opportunity to play around with Blender, which has a whole bunch of Python bindings and a pretty nice Python library, which I'm going to be using for scaling. Um, and then just in general, be my first like 3-dimensional project. So look at that lumpy little thing. Not exactly a same fidelity as a real life dome, but there it is, rendered in Roblox. Still pretty lumpy, but it's kind of fun to go from I typed a thing that said a thing about a dome, and then it gave me a picture, and then I gave that picture to a thing, and then that thing gave me a model, and then I've loaded that model into another thing, and there it is. So Roblox does some generative AI stuff too. You can talk to their thing. It's called Roblox Assistant. It mostly at this point focuses on what's called materials. And so you can basically highlight one of the models that you've got and say, hey, I want to change the material on this. So I told it, hey, could you make a skin that looks like triangles on a geodesic dome skin? And so it gave me some funny looking things, and that's what it looked like. I don't know, almost looks like insectoid or something like that.
Hmm.
Not too shabby. But here's what the refined model looked like. Thought that started to look pretty good. And then posed it up in a bunch of things. Here's like one or two of them. I got a little excited with all the rest of the 3D models. And there it is in the background. There's that initial one on the right. I don't know if you can see in like the bottom just left of center. There's little gray avatar characters. They say rig over their head. If you're familiar with Roblox, it's like a kid's platform. And so the
Right.
default character is basically like a Lego mini figure. So you see little low poly guys. There's a couple more of the dome thing.
Why don't we get started on the
Because I'm almost done here.
okay.
I got a few more slides. Anyway, it's really interesting because Roblox allows you to sell these assets. And yeah. So as I was saying before, we take 3D models and work on rigging. And unfortunately, it's not an exactly automatable process just yet with the state of the art. You end up with some cryptid horrors like the bottom middle, even if you're working with the top left there. And so did some less cartoony things. This was like a Martian spacesuit type character. Top left is a, a generative AI called Luma AI. They first started in the NERF space, which I've talked about in the past, neural radiance fields. But they're now kind of working in the just like prompt and generate models thing. So made some pretty nice models, and then I got them rigged up. At the top right, that's a look at Blender inside of one of those models with what are called armatures. But then that kind of like tees up the Python aspect of what I'm working on, because the bottom left is that model with the skeleton that it's just way bigger than the actual model. And so that's one of the things I'm working on in Python with the Blender library, is scaling issues. And what that one comes from is these Blender and Unity and this thing called Animate Anything. They all output on a metric scale, and Roblox works in the studs scale, which is to say like the little studs on the outside of a Lego thing. So worse than Imperial even. And then, more Python stuff. Roblox has HTTP, not HTTPS, but HTTP connections for data on the player level, and then for like object pipelining on the studio level. And so I'm kind of tooling up all of that. And so we're a Python development shop first. We are pre-funding though. So if you've got any time and you're interested in breaking into the gaming space, we're looking for additional collaborators, any Django devs. or people that know anything about Unity or Unreal, or just generally know something about gaming, reach out to me afterwards. Happy to put you in contact with the head of the project. His name's Ben Pollock. So without further ado, since Robert's chopping at the bit, I want to hand things over to him. Robert has a project for us that he's been working on, Health Universe or something like that, but it uses a tooling called FastAPI. So I'm going to hand it over to Robert. Robert, the floor is
All right.
yours. And
Yes.
there you go.
So yeah, actually, this has nothing to do with Health Universe. This was just a demo app to test the Health Universe platform, but they made some changes to GitHub, so it's harder to find how to actually create a new project. So to get this done, I just use that. But it still works. So why don't I begin by going over Google Colab, and I put a link to it in the chat. And let's do Zoom, share a screen, and we're gonna do, and I'm just gonna say, where am I? Here we are. I'm gonna share that. Okay, so everyone can see untitled2.ipynb, right?
Yeah, could you zoom in the text so that we can read it a little bit better?
Yep. Let's do.
So Hatham, this was the Python environment that Robert was alluding to.
Right. So actually, why don't, since this is kind of a tutorial part, why don't everyone go ahead and click on that link, log in with a Google account, and you're going to get like a welcome screen, and then there should be a way that you can actually create a new document. So anyone who hasn't used it before, this is a chance to kind of walk through it.
I posted that link again in the chat, just in case anyone was wondering.
All right. So is everyone able to create a new document in Google Colab?
It'd be the same thing as a notebook.
Yeah.
Okay.
Yeah. And so you see C and O in orange in the upper left, and you've got like a file name, and you've got your menu, file, edit, view, insert, runtime, tools, and help. And then it should just be a blank one. And I started off by doing 2 + 2, and then I did a Shift Enter, and I got 4, which should not come as a revelation to anyone.
And which Python version is this using?
Let's see here. Import sys. And I think it's sys dot.
It's sys.version, actually.
Is it not letting me? Okay. Is sys.version going to tell me? I think it's actually something a little bit more tricky.
No, it's just an attribute, not a method.
Okay, yeah, it does. So it's giving me that it's Python 3.10.12 and that it's running on, it was compiled with GCC 11.4.
Great, thank you.
It's platform.version. There's platform.version, platform.version. Something else. So one of them will tell you the operating system, the other one will tell you the Python version, but sys.version goes straight to it, which is good. So you can see that I've done 3 things here. The first one it's working like, you know, a calculator. Second one is I'm importing a commonly used Python module called sys, and that has a method or that tells me which version of Python I'm using, right? So can everyone do those two things on their copy? I mean, the ones that are following along. Can you import the sys module, and can you find out what version you're using? And you should be using the exact same version. So does anybody get a different result? Okay, so this is a REPL that everyone has access to, and a side benefit of this is that these documents are easily shareable, right? So the same way that you share like a Google spreadsheet or a Google document, you can share one of these. So should I go over a little bit of basic Python, or should we just get straight into the FastAPI and HTMX tutorial?
Straight to the API, HTMX.
All right. So anyway, that's how you can go about using Colab. And I'm gonna stop share of that, and I'm gonna go to a, let's see here. Okay, so now I'm gonna do share screen again. And how do I get the whole thing? Desktop. Sharing. Right, and now we're going to go to Visual Studio Code. Why? Okay, there I am. Okay, so who has used another Python web application framework like Flask or Django, or one of the more exotic ones? Anyone? Okay, great. So FastAPI is a way to create APIs in Python, and the default way to use it is you have a JSON output, but the basic formula is you have a object, and then you have endpoints, and the way web servers work is you have the HTTP protocol, which has different what are called verbs. So you have get, post, put, delete. There's another one, but all of the endpoints for this demonstration are going to be get. And so when you go and you open up a new web page, your browser is sending an HTTP GET request to that server, and the server gives a response to that, which is the web page. And then from there, the web page is going to request other things that are listed on that web page. And initially, like back in the 90s, everything was generated on the server, and so the server process had access to all the files and databases and those kinds of things. And now there are new ways of doing web development where everything is done on the client, and so they have things like React and Angular and Vue.js, and you can make applications that are entirely client-side. They call them single-page applications, and they don't require you to make a request back to the server. But now there's this JavaScript library called HTMX, and HTMX allows you to, is a JavaScript library that is part of the web page that is generated by the server, and that allows you to make requests with HTML tags, with pretty much any HTML tag, instead of only being able to do it with a form. So let's see here. So let's take a look at the HTMX code in HTML. So basic, I'll go ahead and I'll create another basic web page. Right. So basic web page has a structure like this. So you have between the HTML tags, you have a head tag where you have the title, and then a set of body tags where you have your web page. Now in this application, you have, in this application, we're taking in 3 libraries. We're taking in the HTMX library here. I was experimenting with using an HTMX extension for server-side emits, which isn't quite working, but that's that one. And then this is for Tailwind styling. So there are different CSS libraries for styling your web page. And Tailwind is the—
Hey Robert, could you
Yeah.
increase your font size?
Let's see here. Can I do it like this? No. How do? Oh, I guess I can't. All right.
Thank you, sir.
Is
That's
that
better,
better?
thanks.
Okay. And right. So here, what's an example of a simple web page? Right. So when you do like this, and we put in let's say, sure, no, I can do that. We can do, Yeah, we'll do chart data for that. So normally you have only two elements in an HTML page that can generate a GET request. So there's an anchor tag and there's a form. And for anything else, you have to have some JavaScript on the page in order to have something that is clickable and have it do something. So here in a simple web page, you'd have something like you'd have an href tag, and then in the case of it being on the same server, you just have a slash and then the name of the endpoint. The endpoint is the thing that you call to get some data back. And so in this case, this would take you to another page that just has the result of the chart data. So I'll go ahead and fire up this application. Why does it say base? Oh, and this is the wrong. Here. And if I do Python SacPy, okay, and then I go ahead and click on that link, and I get this. So this is a simple example, and I'll go ahead and zoom this in so it's a little easier to see. And that's plenty easy to see now, right?
Yeah, pretty visible.
Right? Okay. So I click on this and it fills in that table. I click on that, fills in that one. When I click on this, I get a bunch of fruit names. When I click on this guy, it fills in a bunch of sample information. And so this is what you want in a web interface, right? Is you want to be able to click on something and have it respond. Normally, this would require someone to not only be familiar with the server-side code, but also to write client-side code in something like JavaScript or React in order to be able to have that. And so let's take a look at how that works in Python. So back here, so the first endpoint that gets hit is this. So when you just say when I clicked on the link for the server, it called this endpoint, which is just a /, which is the home page, and what that called this template response method of the templates object. And so I have here this code for the home page that I just showed, and then it takes 2 parameters that get passed to that. The request object, so it's for keeping track of a thread of requests, and in this case, a Python list of films. And so initially, it's just going to get a blank list because none of those tables have been clicked on. So when we scroll up here, so blanks is just an empty Python list. Now, when we end up calling one of these lists of actual data, it looks like this. So we have a Python list that has 3 dictionaries with kind of generic information. It's got a name field and a director field for each of those 3 dictionaries. And this is how things are going to get passed. Now, when we go back and we take a look at table rows, right? So this is another template file that only deals with the business of filling in the HTML rows. So it just iterates over this films object that was passed into it, and it writes the table, beginning the table row, it writes the 2 table data columns, and for each column, it uses what's called the mustache syntax with the 2 double braces, and then it has, so films is what was passed in from the Python code, and it's uses the Python for in syntax, and so for each loop, it assigns that to the film variable, and that film variable has a name and a director property. So in this case, it's interesting. It's actually a dictionary, but in Jinja it accepts the dot notation. So let's go back. Here. So we see we've got each of these arrays, and then also I'm going to have 2 list boxes that, instead of being a list of dictionaries, are just a straight list, one of fruits and one of names. And so rather than typing all the open quotes and the close quotes, you can just have a long string and then just say split, and it splits on the spaces. So what do people think? It's very difficult to give a presentation like this when there's just no feedback at all. Or like, does it make sense? Does it not make sense? I constantly talk when people are giving a presentation.
And do you have, if you've got the server running, can you show it returning these values?
So let's go back to, let's see here, where am I? Right. Okay, so let's go ahead and refresh the page. So here it is when we've just called the root object. And when we look at here, you can see down here, we see, so here we see it's a number of different get calls, right? And now, that I refresh the page, we see the /, right? So, so this is where it's actually running the server. And so it comes back and says Unicorn is running on this, which is, so localhost means you can't route it, and all zeros means it is, you know, it's the routable form of your address on port 5001. And then it says that it's using the HTTP 1.1 protocol, and that it came back with you know, a 200 status code because everything was copacetic and it worked.
Do you mean, I have a question. Do you mean like when you say you can't route it, do you mean like you like with ngrok you can like forward that port to somebody, right?
ngrok?
Yeah. Yeah, I mispronounced. But like you could like forward your port, your local host 5001, right? And then someone could access that, couldn't they?
Yeah, I guess so. I mean,
But you're talking about something else with like routing, like
yeah,
you're saying-
within one computer, right? Within one system, one host, I can pass things around between different processes just fine, right? And so on my web server, I have the front end is Nginx, right? It's the Nginx web server, and that handles the HTTPS authentication. And then it turns around and it uses a reverse proxy to forward that to the real server that is running on, I think, 5001 on localhost, right? So it's
right.
So from a different machine inside my network, I can't access the Flask server that's running on localhost because it's non-routable, right?
Oh, okay, I see what you're saying. Okay.
Now I can access it through the Nginx server that, you know, that forwards to it, right? So I can pass things around within one machine. They're all running on localhost, and that's just fine. But I can't pass it to a different machine, or I can't access it from a different machine.
So you can't
Now, when you run ngrok, you're running another process on the same machine, right?
right.
Fine. So it can access it. So ngrok can access localhost just fine.
So but and then you're saying like if I had a computer on the same network locally, I could not go to the IP address, the local IP address of the computer that's running with 5001 and access it from another computer by accessing the IP address of the other computer, 5001. That
Yep.
you're saying that's not routable.
Yeah. So let's say I'm at work and I have two computers, right? And I have the system that's running my server, right? And I have another system that I want to access it from, right? So if it's running on localhost, I can't access it from system B. Now, when I go back and I change it to run on 0.0.0.0 like I have here, now I can access it from system B if I know the IP address of system A.
Oh, interesting. So when it's just when you have your configuration is localhost, right?
Yeah, and this is like a huge thing, is that somebody will get some sample code, and the server will be set to run on localhost, right? And then they'll go like, oh, okay, cool. So we can use this in an office network. And they
Yeah.
go like, why doesn't it work?
Yeah. Yeah. Okay. Thank you so much.
So yeah, so if you want something to be accessible from outside of that computer, you have to use 0.0.0.0, not localhost. Okay, great. So now it's running. And so if you're in cybersecurity, you're familiar with like this log output, right? Right. So it shows, so it was called from localhost 127.0.0.1 port 50792. That's the calling port, right? And then it called with the get method, it called just a /, and that was fine. That worked. Okay, so let's go on to the next one. Here we see it's calling what's called the endpoint table rows, and it's passing 3 parameters, right? So it has a question mark, and then it has, the first one is caller ID equals table 1, and then an ampersand, table 1 or table equals 1 ampersand, length equals 5. And let's take a look at those. Okay, so here we have the table rows method, right? So in FastAPI, and it looks almost exactly the same in Flask, you say ampersand app.get, and then this is the name of the method. It's called table rows, and that's what you see down here in the log, right? And it passed these things, and so yeah, and so here it's so here we see this is my print statement, and so here I'm logging the HX target, that's there, the table number, which I don't actually use, but it gets passed anyway, and that's there. Caller ID is the HTML ID of that element, and then length is just another parameter, right? So let's go back and take a look at, let's see here, this was called from table 1. Let's go back and look in the HTML and look at that. Dude, I didn't mean to do that. Can I get rid of that? Okay. Table 1 down here. This is table, right? So this is so when I look at this log item, right? So it called the table rows endpoint, and we can see that it's doing an hx get to / table rows. I want to tell it what HTML element to change, and that's the target. We'll get back to the other ones. And in HTML, you can give each element a unique ID. And so when you want to update the contents of that HTML element, that's important. You can't, you got to be specific, not vague about that. And this final thing called hx-vals, this allows to pass extra information as these as maybe DN can help me out. What is the formal name for the arguments that you pass here in HTTP?
Are they queries? Query params?
Query parameters, yeah, that's it. So so these three things here are query parameters, and so HTMX has this kind of cool little feature that all these three things that are in this HX vals, and this is like a Java object format, get passed as query params, right? And since this is supposed to be a table, let's take a look. So a table consists of a head and a body, right? So in Tailwind, you have a bunch of these kind of little shorthand notations that you can use for styling things. So we use a border -b and text large to style that the table header. And you need to have a row structure for each row in either a head or a body. And then you need each of these, yeah, so these are table headers for the names of the headers, right? That you specify as a class. And then here it says that what is actually going to get updated is table one body. So in CSS class notation, when you have a pound like that, it means it's an ID. So this is this, right? So this means it's the ID table one body, which goes to there. And here it's going to include the output from this table rows here. And once again, it uses a table row, and here instead of table header, it has table data, and mustache has the film name and film director, right? Okay, let's go back to the HTMX.
So I have a question real quick.
Okay. All right.
About the architecture for this. Are you like, would you I guess technically be good to like, I'm thinking about how React works, where it's like you have just like components and components and components all nested in the app, right? And you're including the table rows, and I'm wondering, like, is it typical in HTMX to have just like a ton of includes, like kind of branching out into like different children, or like what do you like? Is that kind of what happens, or is it kind of just one-off little tables here and there? Is that kind of what it is?
What was your question again?
Can you do like can you do like an include and an inside and include? Like, is that typical for
Yeah,
HTML?
you can do that. You have many layers of nested includes, right? So I think you can do that to the same extent or greater than you can in React.
Right.
And so there was a talk I saw where a project manager in France, and he had a like large website. And originally, this large website was written with a back end in, I think, Django, and a front end in React. And so initially, he needed a team of Python developers for the backend to talk to the database, and a different set of developers to maintain the React front end. And of course, you also need to have coordination and connection between the two teams who are talking in two different languages in order to make this all work. And so then when HTMX came out, he came up with the idea of just go ahead and biting the bullet and doing a refactor. And so the total lines of code was cut in half. And it ended up with just a very small amount of a very small increase in the size of the HTML, very small amount of JavaScript code, and of course, the actual presentation aspect was moved to the Django backend, and that way, the people who were dealing with the backend aspects of it had a better feel for the presentation code, right? Because it's all in one place, and so this idea of presentation logic could be done in either of the two places, where before, in order to have that reactivity of responding to things that are occurring in the browser, you had to have either just a whole bunch of JavaScript code. Well, actually, you end up requiring a whole bunch of JavaScript code, regardless of whether you use plain JavaScript or a framework like React. So this is a way of making this more accessible. Now, of course, you have to be somewhat familiar with HTML and some sort of a server-side language, but that's much easier than trying to master two different languages and do the coordination between them, right? So if as I go over some of the HTML, how is this completely alien to people here? It's fairly easy to read. You can see there's a script tag, and it means this is like an include in Python, right? You're adding some additional functionality. You have these are different element tags. A div is very common, but it's kind of harder to visualize that. A button makes sense. It's something you click on. A table makes sense, right? A table has rows and columns. But what's different about React is you have these things here where it's telling it how to talk to the server, right? And before, you would need either a framework like React or you need JavaScript code in order to do these things, in order for it to be able to respond to a button click.
So I have a question.
Okay.
So like in React, there's like the concept of state, right?
Right.
So the state you're saying is managed on the back. Is that correct?
This yes. It's you're maintaining the state on the back end, and it's forwarding events to the back end, right?
So like I click on something and it sends the event.
And it sends the event back to the server, and it can actually send some additional context back to the server so it knows how to deal with it, right? And part of this, and probably the most important part of the context, is the HX target, right? So HX get is, what do I call? HX target is, after I do the call, where do I put it, right? And so this HTML ID tag So you see a £sign here because this is the way you notate that it's an ID of a specific element as opposed to a class, which is a group or a category. And if you're going to update it, it can't be, maybe like 50 different things on the page. It has to be just one. So this is pointing down to this. So when I call this method on the server, this is the thing that's going to get updated, right? And so now I'm back in the server. When I go to in the table rows method, right? So here I have this HX target that I got bundled in with that information, and okay. So now I'm going to call this method here with that HX target. And then here I'm using a Python 10 switch case statement so that I determine which array I'm going to pass to this template response generator based on that. So I say like, oh, okay, so if it passes table one body, well, then I want this table to fill it, right? So you can see that this is what's going to fill this guy, this is what's going to fill this guy, and this is what's going to fill this guy when they get clicked on. And indeed, that is what you saw. And let's see here.
I'm trying to think of the trade-offs that you'd make between like some of like the more like the front end state that's like kind of more meant for the front end,
Mm-hmm.
and then like because it is nice to have some of like the state, like obviously like the state managed in the back end, but I'm
Mm-hmm.
thinking of like for like animations or like is like I guess like a good example is like is the menu item open? You're saying that state would be managed on the back. Like is the hamburger menu open,
So you can mix and match, right? So let's see here. Did I delete the logging code?
It's like I log in and my hamburger menu is still open.
Right. So yeah, so you can see their HTML behavior can be customized with JS. So you can mix this with some JavaScript libraries, right? So here you see I'm customizing the logger. So every time HTMX handles an event, it's going to write that to console.log, right? Which is the way that you log things in JavaScript. And it can it can be integrated with like jQuery, which is kind of an old standard for adding customizations, as well as something called Alpine JS, and Svelte and Vanilla JS. It plays well with those. So in the event that there's something missing, you can cover those gaps with HTMX, right? In the event that you just have a certain preferences and style for doing things, you could switch to using that different client-side style. But I'd say probably in the long run, you're better off just learning how to use HTMX and committing to migrating it to the server.
Right. Right, I'm just thinking between like handling state between components or something, or between HTMX components.
Uh-huh.
You can do that, right?
You can. So let's switch to looking at HTMX. So this is the website. And it's just htmx.org, right? And I'll zoom in. And here they show a very minimalist application. So here it's doing a post instead of a get, and clicked. And so when you click this button, it's going to call this method on the server, and it's going to replace the contents of this with what the server sends back, right? As far as keeping track of state between the system, I know that it works, but all the details of it, I'm not an expert yet.
Yeah, that's fine. I was just curious of like any limits, you know, like because like one tool has different advantages over another tool, right? Like there's trade-offs, you know.
Yeah. So there's yeah, I would look for you know, YouTube videos, or maybe like Reddit posts to go into that. And I guess aside from that, you just have to look at examples and read through the documentation to really get an assessment for that. But this guy did a pretty good job in terms of, you know, covering all the bases. And as far as, oh, I just want to make a way to, you know, interact with my data, it more than covers it.
Right. Thank you.
Okay, so let's go back here. Right. So there's a lot, I mean, there's a lot of details in this example. So any other questions? So we covered the way that the HTMX JavaScript library, you know, adds new methods to HTML. We kind of covered the basics of how FastAPI has, let's go back to FastAPI, has endpoints, right? And that is what gets called when you do these HX gets on in the HTML page, right? So these are headers as opposed to query parameters, and they're accessible. So this this syntax says the header might be there, or it might not be. If it isn't, you'll get none. And if it is there, you'll get the value of that header. And then it has some special, FastAPI adds some tricks so that, for example, if the actual HTTP method is HX dash target, which you can't use because that the dash means subtraction, right? It needs to change it to an underscore, and so it automatically does that. And this is another thing I was kind of experimenting with, was instead of having a list of dictionaries, to just use comma separated value data, and have that automatically converted to a list of dictionaries. And so here's code to do that. It converts it to a string, and then the dict reader makes it a list of dictionaries, and that way it can create a dynamic table regardless of what gets passed in. It doesn't matter, how many columns you have in the CSV data. Okay, so if there are no questions, I'll stop sharing for now.
That was great. Thank you, Robert. APIs are a huge topic in Python space. All right, well, next month, I believe we're gonna have Nick Shores, who was on earlier today, talking about his haircut thing. Should be fun. Thanks again, Robert, for your presentation. Thanks everyone for coming. We'll see you on the first Thursday of next month, everyone. Have a good night.
All right, good night.
Thank you.
Bye-bye.